Hey guys, this is RamboS, and today this is a quick video to show you guys a little project I've been working on, and it's right in front of you here. It is a parallel 3-axis, doesn't like that, delta robot, and basically, as you heard there are 3 servos connected to these arms, and they move this platform around in 3 dimensions. The whole thing is run using a Raspberry Pi on top here, and a 5-cell nickel hammerite battery powers the servos, while the Raspberry Pi is powered by my 5-volt battery pack. So this whole structure here is made out of cardboard, so really nice, cheap to make, and I think it looks quite good actually, better than I thought it would come out, to tell you the truth. This platform here is also cardboard, although it's not very flat, so I'm probably going to upgrade that in the near future. And what I've done to demonstrate the motion is I've put a little piece of pencil lead in here, and I put a paper on the platform, so the robot, when it moves across the platform, it can draw quite nicely on paper. So I'm going to start by moving him around into a few positions, just to show you that it's capable of moving in all 3 axes. And how I'm going to control it is using a wireless SSH connection to my Raspberry Pi from my computer. And it's a very easy to use interface. When you start up the program, it gives you 3 options: G-code, position, or shape. Forget the shape, that was just for testing purposes and giving it a list of coordinates to move through. So at first we're going to take a look at position. So if I just type in a 2 for the second part of the choice, and then I get an X prompt, Y prompt, and a Z prompt, I just type in the coordinate 0, -150, 0. And as you can see, the robot moved down to that position. From measuring, it's fairly accurate, but there is a fair bit of play around in the linkages just because of the flex. So generally, if it's not touching anything or rubbing against anything, it does pretty well, but when it is, it's less than ideal. But I think I should have a fix for that. If we just move it around a bit. So far, the furthest I've moved the robot and the biggest bounding box I've been able to get is about 120 by 120 millimeters at a height of 150 millimeters down from the base, from this point here down around. But it's quite hard to calculate a bounding box since the motion of the effector isn't in a square fashion. The bounding box is more sort of pan-shaped. So if I just move it to... And another thing, at the moment I haven't put any correction if you were to type in something further than the bounding box. So as soon as I definitely find a bounding box, then I better add that in, because otherwise it just glitches out and breaks and tries to move to an impossible position. So yeah, that's a problem I gotta work out. So if I just lower it down, X coordinate, that's another thing you gotta be careful of if you type in the wrong ones in the wrong place. If I just lower it down a little bit, so now it's almost touching the page. And so there we go, we can move it around like that, but I thought it would be much easier if you could use some sort of a file to give it a picture and it could draw in that fashion. So I have a file here. It's a bunch of circles inside each other, 4 of them. It's a PNG file, and what I've done is all these pixels are white, so I've increased the contrast as far as it'll go. All these pixels are white. All of those on the thing are fully black. So that's quite important with this code, and so if we run a program It's a Python code called point finder. Yep, and it'll give me a prompt to enter the file to be cut, and the file is called concentric circles. .png, it is important to put that in, and I'll just start this up, and while it's running I'll talk to you about how it works. So there, each time it's printing the letter P, it's detecting a point from this image. It's using the Python imaging library, PIL, which is the main reason why I've used Python here. Yeah, I've used Objective-C for the actual inverse kinematics, which I've used to calculate the angles of each of the servos. So here we've got a prompt that says enter y coordinate for the 2D shape, and because obviously the picture only gives us the x and the z coordinates for the robot, we need a y coordinate, which is basically the height at which the end effector, the pencil lead, touches the paper nicely. So with a bit of experimentation, I found that it's 177, I think, something like that. It's not too fussy if you're more or less right, but yeah, and then it'll give you an option for the scale factor, which a factor of 1 means 1 pixel is 1 millimeters. So I'm going to put 0.1 because the image is about 755 pixels or whatever, and yeah, something like that, and it works out quite nicely, 0.1, but that's something you could calculate for a proper image if you wanted. Now, for the filter radius, it's the distance between 2 points, and because servers only update at a certain at a certain rate, if you put 2 pixels very close to each other, the servers are barely going to be moving, and they're just going to be moving so slowly it's not going to work very well. So if you put 1, then all the points are at least 1 millimeter apart from each other, so that gives it a nice speed. You can do 2 as well, that'll probably work, and it'll give it a bit of a faster speed. So basically when it says filtering, it's getting rid of all the points that are too close to each other, and it's only leaving the ones that are 1 mil apart. That makes it much easier for the Raspberry Pi to calculate the kinematics as well. So here it's sent over the file via SSH to the Raspberry Pi, so I'm going to move over to the SSH controller, and if I just start a new code window. So, how did that get unplugged? Did it come out or something? Okay, right. If I just start a new program, and I'll just lower it down to almost near the paper so that it doesn't jerk around at the end. And then if I press this, it should start calculating. It might take a while to calculate, and then after that, after it's calculated all the points, the angles that the servos need to move to reach all the points, it'll start going through with a set delay. That way I have much more control over the process than if I was calculating while doing it. So you can see it's printing a whole load of stuff which I set up for debugging purposes when I was only testing with 1 point. But I'd probably get rid of that at some point, but for the moment I think I'm just going to leave it since it's not really bothering me, and it looks pretty cool as well. Generally this takes about a minute or so. If I just check the size of the file. Oh, there we go. Off it goes. Just opening up the G-code file. You can read it, and it's all in text, which is really nice. As you can see, the robot jumps over for each circle that it draws. And just nicely draws round. Well, maybe not so nicely, but draws round. And that might be it. Why did that last stroke happen? I'm not exactly sure why that happened. It doesn't usually, but if I just start a new program and entering the number 4 here shuts it down. If I just move that all the way up, then you can see here that it's nicely drawn on the paper. So yeah, that's about it. I just wanted to show you guys my cool little creation, and for future things I'm trying to do with it, I'm possibly thinking of making a 3D printer with an extruder on this area instead of the pencil, possibly a knife to cut paper, like some sort of a vinyl cutter. But really, one of the major drawbacks is the fact that it draws pretty jerky. It's not smooth, and you saw with the motion, it doesn't stay smooth and neat through the circle, which is a real drawback, especially for 3D printing, or CNCing for that matter. There's no way you're going to be able to get that motion and cut a nice shape, or make a nice shape. So that's something I'll have to work on, and mostly it's actually because of the whole thing is quite flexy. I mean, the base from the top part as well, that causes flex, and then these rods themselves bend. This tilts quite badly actually. So in some ways it's better than what I was expecting, considering the whole thing's made out of cardboard and a little bit of plastic, but there's still definitely a long way to go before I get 3D printing stuff or anything like that. So that's about it. This was RamboS. If you liked the video, please do give it a like, and if you want to see more, subscribe to our channel.